to see the first concept is called a schema and instance. So what happened in the database management system? There are two, you can see entities. One is called a schema, and another is called instance. Now, what is a schema? So schema is nothing but logical structure of the database. Now, what do you mean by logical structure? See, what happen is when you visualize a database, so database is nothing but the combination of uh, similar type of data, right? And these similar type of data should be stored in an organized way. Okay. So the organization of these data, when we define, so that will be defined in the form of a schema. Schema means what are the different column names under which data will come? What are the data type of that particular column name? What should be the size? Means how many character of one particular uh, instance can have, or one particular record can have, and what are the other properties related to the data that is there in the database. So it will tell about this structure that is called logical structure, which is not actual data, which is telling you about how your data is organized. So that is called schema. So you must have seen that the type and the variable in the programming language. So what is the type that is there is nothing but your schema. So the database consists of information about the set of customers and account and the relation between them. That is called schema. Means we have to define first what type of data we are expecting, what are the different column name that we are expecting, and what are the different types of data that we are expecting. So that is actually the schema. So previously means initially when we take the data, before that we should design the schema, and after designing the schema we are able to take the data. So this is the first process before taking the data into the database. It is analogous to type information of the variable in the program. So what is the type of the information, right? Means if we'll define the data type, let's say int x, it will tell you that x is nothing but an integer type, and it will take a certain, there is a certain length of the integer, right? Beyond that it cannot take in, and it will also tell you that what is the property of that particular variable. Means it is a numeric number as well as it is not a floating point number. It is the whole number that we are taking. So int x will tell you like this. The schema is also used to tell you like that. So there are two type of schema, physical schema and logical schema. So physical level means the very bottom level. When we store any data, we design the physical schema. Means at the very bottom where your data is stored, means into the hard drive when your data is stored in the digital form. So which type of structure they are using to store the data. So it may be the B tree or B plus tree that we'll see later on. So those type of data structure is defined. That is called physical schema. And what is a logical schema? So in the logical level, it means that what we can visualize, let's say we visualize the database in the form of tables. So that table that will define where we have number of rows, how many number of rows it can take, how many number of column it can take, what should be the name of that particular table, what should be the name of the columns, all those things, as well as what is the relation between two or more tables. So that all those things is defined under the logical schema. Getting it? So that is the schema. Uh, Later on in the course, you will easily understand what do you mean by that. The next is called instance. Instance is nothing but the actual data, actual contents. So the actual content of the database at a particular point of time, that is called instance. Means at, let's say at time t1, how many records are there in the table, right? So that number of record is nothing but the instance of the database. And let's say at time t2, there may be more number of data that is there in the database. So that is called instance of the database. It means the actual data. It is analogous to the value of the variable. So instance is similar to the value of the variable. Any variable, when we give the value, that is called instance. In the same way, when we put the data inside the schema or inside the structure of the database, that data, actual data, is called instance. Okay. So if we'll take an example, so if we have the student schema, means student database, and we have the name, roll number, class, marks, course number, department. If we'll define all those things, these are nothing but the column names. So when we define all those things, is called schema, right? So in other words, the description of the database is called database schema. Description, right? How we'll define it, which is specified during database design and is not expected to change frequently. So so as I told you, initially we define the structure or the schema, that is called a schema, right? So it is not going to change, means generally it is not going to change, but we can change it. If we want to update or we want to add some more column, we can add it. But initially we used to create the structure of the database in the form of this, as an example, as you can see. So this is called schema diagram. The schema diagram displays only some aspect of a schema, such as the name of the record type, data items, and some type of constant. Other aspects are not specified in the schema diagram. It does not specify the data type of each data items and the relationship among the various fields. So it tells you that how many columns are there, what are the different name of the columns, what are the name of the table, what is the data type of each columns, means what type of data we are expecting in each columns, what is the length of it. So all those things are defined when we define the schema. Okay, now let's talk about instance. So instance is nothing but actual data at any particular time. So the database changes over time when information is inserted or deleted, right? So these are the information that we are talking about. P1, P2, P3 is coming in product number. Then we have product name, and then we have product and its price and city. So as you can see, at any time T1 or at any time T, there are three instances that we can say. This is one instance, this is another instance, this is another instance. So one instance is nothing but one record that you can say. So this is one record or one row, you can say, which is inserted over the time. Or it doesn't mean that you are going to always insert the values into the database. There might be some time when you have to delete some data from the database. So at a particular time, what is the status of your database, means how many data is there, or how many actual value is there inside your database, that is called instance. So the collection of information is stored in the database at a particular moment is called an instance of the database. The overall design of database is called the database schema. So the overall design, as we know, that is called a schema. And at a particular time, the data inside the table is called instance. So I think the concept is clear to all of you. So in the last class, we have talked about abstraction of database, and we know there is a 3 level of abstraction. Now let's talk about data independence. What do you mean by data independence concept? So the concept of data independence says that is a type of data transparency that matters for a centralized database. It refers to the immunity of user application to make changes in the definition and organization of data. So what it want to say is it refers to the immunity of user application to make changes in the definition and organization of data. See, what will happen is database is the backend, right? And when we develop any software, so there is a front end and there is a back end. In the back end, where the data is handled, that portion is called database or database management system that we'll use in our application. And there is a front end. So in the front end, we write some code so that we can get some data from the database. We can uh, as well as from the front end, a database can take the data into the database. So whatever we define into the application, that application should be immutable. That is saying that that the whatever we define into the front end will be independent to the backend, means your database. So whatever we do into the database, your front end is not going to manipulate much. That is the objective of data independency. So we have 3 level of abstraction that we know, that if we do any changes in one level, it should not affect another level. That is called independency. That is called isolation, right? So that is defined here in the data independency concept. So it says that it refers to the immunity of user application to make changes in the definition and organization of data. Physical data independence deals with hiding the detail of storage structure from user application. So that we know that the physical data independence deal with the hiding of detail of the storage structure. Means in the physical level, how your data is stored, that is not being defined into the application level. Means application level and your physical level both should be independent to each other. If we do any changes in one level, it should not affect the other level. That is the meaning of independency. But we can achieve only two type of data independency here into the database management system. So what are the two data independency that we can achieve here is, so there are logical data independency or there are physical data independency. Okay, let's see one by one what are those data independency is. So what happened into the logical data independency? This is telling you about the ability to change the logical schema, right? Logical means your conceptual schema. It means the structure of the database is called schema, right? So the ability to change the logical schema without changing the external schema means your user view. So whatever your user can view, if we do not affect that and we do changes in the logical level, so that is called logical data independency. It means that we can change the logical data without affecting the upper level, which is called user level data. That is called logical data independency. For example, the addition or removal of new attribute or entity, attribute or relationship to the conceptual schema should be possibly without having to change existing external schema or having to rewrite existence application program. So what it is saying that if we do any changes in the logical level, it should not affect the user level. Okay, that is the meaning of logical data independency. In the same way, if we'll say physical data independency, it means if we do any changes in the physical schema, it means that how your data is stored, whether it is using B tree, B plus tree, whatever data structure it is using to actually storing your data, if that is not going to affect the logical schema, then it is called physical data independency. Means it's upper level. Physical level is the bottom level. Then we have logical schema, logical level, which is telling you about the logical structure of the database. And then you have view level, where each and every user have different views related to the database. So it says that if we do change anything related to physical schema, it will not going to affect, or it is not going to change the logical schema. Then that concept is called physical data independency. If we'll take an example, a change to the internal schema, such as using different file organization or a storage structure, a storage device, or index strategy, should be possibly without having to change the conceptual or external schema. So that is the meaning of physical data independency. Means the lower level, if we change in the lower level, it will not affect its upper level. That is the meaning of that independency. So we have two level, right? Logical level, logical data independency, and physical data independency. Data independency implies in all those things. It means that whatever um, we we have into the database, that is independent. It means that it implies that the application program should not need to know any of the following. So what are the things that application program doesn't has to know? Means the front end doesn't has to know. First of all, the ordering of data field in the record. So whatever ordering that we are following to put the record into the database, that should not be the problem with the application program. What is the meaning of ordering? Let's say if I want to put the student's record, okay, and I am putting, let's say, roll number one record, roll number one, this is the name, phone number, in all those things. This is one record. Then I am putting roll number two record. This is the name, and then roll, it's a phone number, it's branch, and all those things. That is second record. And then in third record, if I am putting the roll number seven, then I can put it. There is no issue on that. So ordering of record doesn't matter. Second, the ordering of record in the file doesn't matter. Third, the size of each record doesn't matter based on the application program. So whatever the size of the record is, it doesn't have to bother in the application program. Means it's upper level. The size of each field, the format and the type of each data items, whether the file shorted or not, the type of data structure being used to store some of the data. So all those things is insignificance, or it doesn't mean to the application program. So whatever ordering of the data field in the record, it doesn't matter. It means that in the field, let's say we have first column is, let's say, roll number. The second column is, let's say, name. The third column I'm putting as a, let's say, phone number. And the fourth I am putting as a branch. And my application is expecting the third as a branch. So it doesn't matter. So I'm putting the column name, or I'm putting the records, whatever order I want, I can add it into the logical schema. It will not affect the application program or the upper level, or where we'll write the applications, right? So the backend, whatever backend will manipulate, it will not going to affect the front end. That is called data independency. Now, mapping of database management system architecture. Okay, let me, okay. So what will happen is there is just like the data independency between three layers. Here we have the concept of mapping. So how we can map one level to another level. So how this mapping will takes place into the database management system architecture. It says that we know that three view levels are described by means of three schemas. These schemas are stored in the data dictionary. The database management system. In the database management system, each user refer only to its own external schema. Hence, the database management system must transform a request on a specified external schema into a request against conceptual schema, and then into a request against internal schema to store and retrieve data to and from the database. So it says that as a user, we have different view. So some user can see the external view, that is view level. Some user can see the conceptual view, that is logical level. And some user can see the physical view, that is how your database is stored. It says that how the database is transforming the data from one level to another level. That is the concept of mapping. Means the request that is sent in one level, how it is communicated to the lower level, and how the reply from the lower level is going to the upper level. That is called mapping. So this is that concept is called mapping in the database management system. The process to convert a request is whatever request we do from the external level. The request between view level is called mapping. The mapping defines the correspondence between three views level. The mapping described is also stored into the data dictionary. The database is responsible for mapping between these three type of schemas. There are two type of mapping. Okay, so as we know that there are three levels, right? So there is external level, conceptual level, and physical level. External level is nothing but your view level. Then we have the conceptual level, and then we have the physical level. So how your request from the external level is going to the physical level. It means that, let's say as a user, uh, I want to deposit some money into my account. So that is my request. So the banking database will pick up my data and will add these much of money into my account. That is the meaning of deposit, right? So the request I'll fetch into the, and means I'll give into the database from the external view, and then slowly it will map to the physical view or the physical level, do the changes into the actual database, and it will reply you back that this is the current amount or current balance you have. So that mapping, whatever mapping will be done between these three levels, are nothing but the mapping in the database management system. So there are two type of mapping: external conceptual mapping and conceptual internal mapping. So we know that there is three level, right? So the first level is your external level, means your view level. We give any request into the view level, it will go to the conceptual level. So there is a one mapping. And from the conceptual level, your request will go to the physical level, which is your internal level. That is another mapping. So there are two type of mapping, as you can say: external conceptual mapping and conceptual internal mapping. External means your view level, whatever request we give into the database, it will go through the through the external level to the conceptual level. And again, from the conceptual level, the request will go to the internal level, which is your physical level. Okay, so that is called mapping, and the mapping will be take care by the database management system, because we don't know internally how commands are going through and what type of command they used to take. I know only the external command, right? And so from the external command, I initiate the request, and it will go to the internal level through the conceptual level by mapping the request. Okay. That is the meaning of mapping. Now, let's talk about the structure of the database management system. That is a very biggest structure that we'll see. So the database management system act as an interface between the user and the database, right? Because the actual database is there, and there is a management system which is going to manage the database, and this management system will act as a interface. And why it is acting as an interface? Because if the database management system will not be there, then it is the whole sole responsibility of the user to maintain all the thing, to maintain the data, to provide the security into the data, how to retrieve the data, how to add the data, how to update the data. All those things will be the headache of the user. But because of the concept of the database management system, it is a very easy task between the interface of the database and the user. It's just like if I want to use the processes to execute my program, I need the operating system or the kernel, right? Without the operating system, I cannot run any program, or without the operating system, I cannot execute any program, or I cannot use the hardware, right? So if I want to use the hardware, that is my laptop, right? So I should have some sort of interface, and for me, the interface is operating system. In the same way, as a user, if I want to use the database, the interface is database management system. So it will take as an interface, and the request the database management system to perform various operation like insertion, deletion, updation, retrieval into the database will be done by the database management system. The component of the database management system perform these request operation onto the database and provide necessary data to the user. That is the responsibility of database. Means it will do all the updation as well as whatever data is required by the user will be provided by the database management system.